So we looked at permutations in a previous lesson, and now we want to look at something called combinations. Now, the difference between the two, just so you're aware, that with permutations, order was important. The order in which we put the items once they'd been selected was important. So ABC was different from ACB and so forth. Okay, but combinations, order is not important. And in terms of when you're identifying a question, okay, one of the most important things is to say to yourself, whatever the scenario is being painted, does the order of the items make any difference or not? So we had a race. You may have some person who comes first, some person who comes second, and someone who comes third. And then they also runs, and the order of the first three people is important. Whilst if you're just saying, right, okay, I've got a bunch of people and I want to select three of them, and they're just going to be representing that group, and the order in which they're selected is of no importance whatsoever, they're just being selected, then that's a combination. The order is not important. Let's go through examples. Let's go through the terminology. Let's go through the notation. Let's go through a formula and then how we use it. And then we'll try and do some examples. So if we take first the notation. So the notation will be, you'll see it in a variety of different ways. You might see it as NCR, where N is above the C and then the R is below it. You might see it written where the N and the R as both as suffixes, or you might also see a notation where it's just an N and an R, one above the other. There's no line in between. It's not a fraction, and in brackets. Whichever one of those three you might see, and indeed you can use them, whichever one you like, whichever one you prefer. There is a formula that calculates a combination. I'll go through some examples to give some practical use of this. It says n factorial divided by r factorial multiplied by n minus r factorial. Now the key thing to be aware here is when you're using combinations, that formula is given to you in the formula book. You can use it. You might find there are other ways in which you remember it and apply it. I'll go through an example to explain. So let's just say, for sake of argument, we have 7 items and we want to choose 2. We don't care the order in which we choose them. We're just choosing 2 of them. So I can write it as 7 combination 2. I might write it as 7 C2 like that, or I might write it as a 7 and then a 2 underneath with brackets. Whichever way it's sort of written or asked, the calculation we would do will be 7 factorial divided by 2 factorial multiplied by 7 minus 2 factorial. Now, generally speaking, you're going to be able to do that subtraction in your head. And if you appreciate that this n minus r is effectively just the difference between these two numbers. So rather than actually writing this whole thing out, I might just say to myself, well, I know the difference between 7 and 2 is 5. So I'll just say 7 factorial divided by 2 factorial multiplied by 5 factorial. And you can bang that out in your calculator and get an answer. And we do that calculation, we get the answer 21. Now just note very quickly, when you're multiplying together 2 factorials, you have to have a multiply sign in between. The calculator will give you a sort of a math error if you just try and write it out literally as you see it here. You have to have a multiply sign in between. But anyway, the answer is 21. So just very quickly, before we go any further, let's just look at that expression 7 factorial divided by 2 factorial 5 factorial. Just be aware that you remember from your definition of factorial that it's 7 multiplied by 6 multiplied by 5 multiplied by 4 and then 3 and 2 and 1. That is the definition of factorial. And we have on the denominator, we have 2 factorials, that's 2 multiplied by 1. And we have 5 factorial, this is 5 multiplied by 4, multiplied by 3, multiplied by 2, multiplied by 1. And you can see there that you've got some factors on the top that can be cancelled with some factors on the bottom. And what you end up with is actually, as a calculation, just 7 multiplied by 6 divided by 2 multiplied by 1. By the way, I'm using dots here as a multiply sign rather than actually having loads of multiply signs out, just as the dot means multiply. So 42 over 2, so that gives me my answer of 21 as previously worked out on the calculator. And in fact, when you're doing a combination, okay, if you want to appreciate this idea of that cancelling going on, i.e. this n minus r, all factorial, cancels out some of the factors within inside the n factorial, you can actually come up with a sort of a calculation to do quite quickly. So I'll just go show you what I mean by this. So what I'm saying to you is when you're doing 7 combination 2, what we're going to have on the top here is two numbers starting at 7 going downwards. So 7 times by 6 on the top, and then starting at 2 going down 2 numbers. So 2 multiplied by 1. So let's go through an example. If I actually, for example, had 9 combination 3. So what I could actually just write out, rather than the whole thing, rather than doing this formula, use of the formula, or indeed writing out the individual factors, I can just say to myself, well, I know it's 9 going down 3 numbers divided by 3 going down 3 numbers. So I started at 9 and I'm going down 3 numbers, and then on the denominator I'm starting at 3 going down 3 numbers. So when I do that calculation, I'm basically going to have 504 divided by 6, which is equal to 84. So what that means is there's 84 different ways in which I could have 9 people and I choose 3 of them. Now that seems unreasonable. It seems bizarre that you could have so many different ways in which you could choose 3 people out of 9. But it's correct. Just to say, however, we can use the function that's just above the divide sign there. We can shift divide in order to actually get combinations as a function programmed into the calculator. So for the sake of argument, if you wanted to do 7 combination 2, we just type out 7 shift divide and then 2 and press equals. We get a 21. If I were to do 9 combination 3, so 9 shift divide 3 equals, I get my answer 84. So it depends on what you're being asked for. If you're just wanting to work out the combination, hey, just use a calculator. If you're needing to show a bit more process or the way in which the question's worded, you're required to break it down a bit more, well then you might want to use a formula to be able to use factorials to get your answer. So let's do some examples, some practical examples. So how many different ways can we choose a team of 5 players from 9? So again, the key thing is order is not important. We have 9 people and we want to choose 5 people to play the game. Okay, we're not worried about their positions on the pitch. We're not interested in who's the best player and who's the 5th best player and so forth. We're just going to have 5 people. So to do that, we're going to have 9 combination 5. So you can bang that out in the calculator, but just very quickly, I'm just going to keep reiterating the point. So this is 9 factorial divided by 5 factorial, and the difference between those two numbers, factorial. You can do that calculation, or you can say to yourself, well, this is the same as 9 going down 5 numbers. Divided by 5 going down 5 numbers. You could sit and do that calculation, or you could just use your calculator and be able to just say yourself 9 shift divide 5 is equal to 126. In part 2, we're being asked about, well, there's one certain player that must be selected. Okay, so i.e. of those 9 people, one person is a shoo-in. They're an absolute certainty, and the only thing that needs to be organised is from the other 8. Okay, who's going to be the other 4 people? So what we're saying is we actually break these 9 people into 2 groups of 1 and 8. So from that individual person that we consider to be vital, they may be the goalie, they may be an extremely good football player, or whatever team game it is. So from one person, we are going to choose that one person, and from the other 8, we are going to choose 4. So 1 combination 1. It seems like a bizarre waste of ink, maybe. Okay, how many ways can you choose one person from 1? Well, that should be fairly obvious. 1 combination 1, there is one way of choosing them. And then the 8 combination 4, we have 8 shift combination, shift divide, and to get the combination 4. And that's 70. So there are 70 different ways in which we can choose effectively 4 people from 8, because one person is the 5th person, the extra last person is a shoo-in. The next example, the first part's reasonably straightforward. In how many different ways can a group of 5 be selected from 10 people? Okay, so again, we've got 10 people, and we are choosing 5. So again, you can write out what that is as combinations. So it's 10 factorial divided by 5 factorial, and the difference between those two is another 5 factorial. You could sit there and do 10 times 9 times 8 times 7 times 6, or divided by 5 times 4 times 3 times 2 times 1, if you're just writing out the factors. Or you could just write out 10 combination 5, and we get our 252. There's 252 different ways in which we can have 5 people out of 10. Now, the next part, in how many different ways can this group be selected if 2 particular people cannot both be selected for the group? So we've got 2 people who, for whatever reason, can't be together. Okay, maybe they have a personality clash. So if one's chosen, the other person is not going to be in the team. Now, this is not as simple as you might think it is, in terms of if you try and say, actually, well, I'll just choose one of them, and then I'll choose another 4 people. And then we also got another scenario where the other person's chosen, and we've got 4 other people. But that won't take into account the possibility that neither of them are chosen. So there's too much complexity, okay, in some respects. So you've got to be slightly careful about this. So the way that this sort of question is dealt with is what you actually do is you look at not what is possible and all the different ways in which it might be possible, but what you do is you think of the opposite. You think of what is not possible, what doesn't fit the criteria. In this instance, what doesn't fit the criteria is these 2 particular people being chosen and both being in the team. And then what you do is you then just discount them, take them away from the total possible. We already know what the total possible is 252. So all we need to say to ourselves, well, let's just imagine these 2 difficult people are both in the group. Okay, so that then leaves another 3 spaces to be filled from 8. So we work out 8 combination 3, and which is 56, and we say to ourselves, we're going to do a subtraction. So we have the 252 people. The pen's going to work for me. 252 2 different combinations, and we're not going to include 56 of them. The pen is being very difficult. So 196 different ways in which you can have 5 people chosen from 10, where we're having to not deal with the 56 scenarios where those two difficult people are both in the group. There's no other way of looking at it. Similar to one of my first examples where I had a situation where one person was definitely chosen, we can deal with two groups. It's just that multiplication that combines the two scenarios. So we have, in this question, we have 4 men that need to be chosen from 7, and separately we have 3 women that need to be chosen from 5. So we set out, we say, right, we've got 7 men. My pen is just being really difficult now. So 7 combination 4, that deals with the 4 men, and from 5 women we are choosing 3. So you can work out those as steps. 7 combination 4 is 35. My pen is being difficult again. Why, oh why can we just be in normal school? Combination 4 is 35, 5 combination 3 is 10, so the answer is going to be 350. Just very quickly again, as long as you show the combinations that you're going to calculate, you could sit here and just type out the whole thing in one go and just press the equal sign, you get your 350 straight away. Moving on to the last example. Example 4, in how many different ways can a committee of 6 be formed from 5 teachers and 8 students? That's 13 people in total. So you'd think that's 13 combination 6, but it requires specifically there to be more teachers than students on each committee. Seems very unfair, outrageous. Anyway, so how are we going to do this? Well, if you're going to have a committee of 6, I suppose, it's worth appreciating what are the different ways in which you can get that scenario. So we can have 5 teachers, and because this committee is 6, we can have 1 student. That's one scenario. We could have 4 teachers and 2 students. That would also give us a 6, and also give us more teachers. Now, the only problem is there's no other combination, because if you think about 3 teachers and 3 students, okay, it doesn't fit the criteria where there has to be more teachers. So we only got 2 scenarios. So you just work out the separate amounts, and then we'll add it together afterwards. So we want 5 teachers from 5. Okay, so literally it's 5 combination 5, and we've got 8 students from which we choose 1. So 5 combination 5 is 1. Pen is playing. And 8 combination 1 is 8. So there's 8 different scenarios where that would occur. And I mean, at the end of the day, if you think of the logic of that, I mean, if you're choosing all 5 teachers, that's just done. You're only just saying, well, which of the 8 students can be chosen? So there's only one of 8 choices. So that seems from the logic of it, seems straightforward. In terms of the 4 teachers, well, you've got 5 teachers and you're choosing 4, and that multiplication that links the 2 up, and you've got 8 students from which we are choosing 2. So 5 combination 4 is 5. 8 combination 2 is 28. So that works out as 140. And so total number of different ways in which you could get those type of scenarios would be 148 different committees.